Good morning, everyone. This is Daniela Pistoia, Corporate Chief Scientist at Elettronica Group, and welcome to this webinar talking about technologies for future electromagnetic spectrum operations. Electromagnetic spectrum is much more than a contested and congested resource. Today, it is also constrained and continuously changing. And every military-supported intelligence, homeland security operation relies on the capability to access and exploit the electromagnetic spectrum. Therefore, physical and virtual domain of warfare increasingly depend on the EMS access. Modern forces are required to operate within an increasingly complex electromagnetic environment, which has been recognized as an operational environment by NATO. A new operational discipline has been set up accordingly, named Electromagnetic Spectrum Operation, or EMSO. EMSO consists not only of traditional EW, which remains the combat discipline of electromagnetic spectrum operation, but includes several other disciplines which operate in the electromagnetic environment, such as information operation, SIGINT, spectrum management, and cyber electromagnetic activities, or CIMA. As electronic warfare has evolved from isolated operations in the EME at tactical level towards joint electromagnetic spectrum operation at strategic and operational level, electronic warfare remains the combat discipline of EMSO and nowadays includes also navigation warfare. Commanders are tasked to attain the level of superiority required to enable effective friendly forces use of the electromagnetic environment, while simultaneously exploiting, preventing, and reducing the adversary forces' electromagnetic environment usage. NATO doctrine recognizes that NATO operations are complicated by an increasingly congested and contested electromagnetic environment. All modern forces conduct operations that depend on the use of the electromagnetic environment. The recognized need for military forces to have access to and utilize the electromagnetic environment creates vulnerabilities and opportunities for electromagnetic spectrum operations. Today's communication, sensing, and guidance devices, whose function depends upon electromagnetic energy, are increasingly used both alone and in network arrangements by civilian and military organizations. It is clear that EMSO demands a level of coordination and synchronization which is impossible without specialized capabilities that support electromagnetic environment, situational awareness, coordination, and priority of actions. Therefore, command and control of electronic warfare is growing as a worldwide need, including development and implementation activities associated with the supporting functional service, such as mission simulation, mission support, and training. EWC4 is part of C4ISTAR inside C4ISTAR deployment with specific role and rules of engagement. ACIDS is our corporate solution. ACIDS supports integration, coordination, planning, execution, assessment, validation, and debriefing of the operational functions SIGINT, EW, cyber on radio frequency inside the larger C4ISTAR. ACIDS includes spectrum management, EMSO wargaming as support functions. This is a first example of application of this concept. It is referred to a ground-based air defense scenario in potential high-intensity level of crisis. The primary mission of GBAD is area defense. Facilities to be protected are localized over a large area. A super coordinated command and control post coordinates all defense activities for the defended area. It combines all available sensor data and performs a threat analysis. Target engagements are then delegated to the subordinated forces. A need of specific point area is also expressed to defend a military airfield or a critical infrastructure against airborne threats, and the command post is linked to the higher echelon that provides an integrated air picture of the specific layer. A secondary mission of GBAD is surveillance. Plethora of sensors distributed across the layers support surveillance and situational awareness within a larger area by locating, identification, and tracking of air vehicles. EMSO have a key role inside this deployment. EMSO provide effective early warning capability. EMSO provide earlier identification of threat such as type, capabilities, payloads, behavior, and so forth. They represent a value tool in command hands during decision-making process and provide strong countermeasure as any type of jamming and deception, both standalone or in support of hard kill. Finally, represent a source for information gathering for intelligence units. This is a second example of application of this concept. Wingman aircraft, both manned or unmanned, with escort jamming capabilities deployed around the intruder package can cooperate to create an electronic denied area. The escort jammer aircraft are closer to the threats in a stand-in operations and take the advantage to be in advance in the time scale with respect to the defended platforms. In case of search radars, this will give the possibility to create false targets closer to the threats, also in case of radio frequency agile radars. In case of tracking radar, this will prevent the range gate to catch the protected aircraft echoes because one or more closer credible targets, coherent, are created. This will imply also a smaller amount of power needed to have enough jammer to signal ratio because of the less distance of the jammer to the radar with respect to the defended platforms. A new paradigm is growing. It is referred as NUC. N is for net-centric, networked systems with very high-speed communication links to have constantly a clear and real-time picture of the environment of conflict and a distributed flow of command chain, actions and reactions. U is for unmanned, remotely pilot vehicles to decrease the level of risk of combat people, enhance the line of horizon, possibly boosted by swarm intelligence and autonomous capability to control guidance and payload configuration on the fly. C is for cyber, capability to exploit vulnerability of computing systems, even via the electromagnetic spectrum, to degrade or delay the decision-making process of the adversary by interacting and interfering with the information or application layer. Collaborative EW is the new frontier of electromagnetic spectrum operation, and despite of its name, is not limited to EW, which is and remains the combat branch of EMSO, but influences also SIGINT and spectrum management in general. In fact, collaborative EW firstly encompasses cooperative engagement capability as the availability of a sensor network distributed in all domains of warfare, plus tools and infrastructures combining data from multiple search sensors into a single real-time composite track pictures. Secondly, but equally important in operations, A real breakthrough is envisaged in the transition of electronic attack, both offensive and self-protect, from coherent to cooperative up to collaborative. In fact, coherent electronic attack, the traditional capabilities, focused at the precise phase and timing requirements to produce sophisticated jamming and deception strategies. This includes the modern cognitive, artificial intelligence-based algorithms that can drive system adjustments at the speed, precision necessary to produce coherent effects. Cooperative electronic attack is related to trends and advancements focused at combining electronic attack systems for increased performance. On-board jammers and off-board decoys coordination is the simplest example of such an application, while, generally speaking, cooperative electronic attack includes potential jamming deception strategies that can optimize electronic attack resources between different types of electronic attack systems. Finally, collaborative electronic attack encompasses trends and advancements focused at generating broader electronic attack effects at the operational level, which includes the optimal allocation of limited assets over a longer duration and broader geographic areas than electronic attack support to single target area and short time on target. Therefore, collaborative EW implies a multiple-layer collaboration: standoff, stand-in collaboration, sensors collaboration, man-machine collaboration, manned-unmanned teaming, blue-on-blue collaboration, and interoperability. A big impact to collaborative EW will be given by the envisaged proliferation of unmanned platforms. Applying collaborative EW and SIGINT function in such cases means subdivide the whole function in sub-functions that could be realized in small payloads, be able to coordinate the platforms in a way to reconstruct the whole from its components, count on a communication infrastructure which has to be solid, trust, and capable to manage synchronization of data gathered using different platforms. Plan the mission according to the platform endurance. Operational implication refer to command and control and decision-making process, mission planning for distributed tasks, reconfiguration during mission, multi-domain distribution, time, frequency, space of sensors and effectors, and cyber resilience. Adversaries are aggressively fielding electronic attack and cyber technologies that erode the ability to use the spectrum for joint operations, while the global wireless broadband industry is seeking to reallocate spectrum from defense to commercial use to meet consumer demands for greater mobility and data connectivity. The development of cognitive radios, cognitive radars, and cognitive networks has introduced wireless and network devices that enable the overcome intelligently adversity to maintain a desired level of performance also in hostile spectrum conditions. These systems have inspired the idea of cognitive EW as the capability to interface and master the spectrum with devices that intelligently finds and exploit vulnerabilities in the spectrum to create highly specific effects, including cyber effects. The leap towards cognitive technology is one of the most exciting trends in EW today. The idea is bio-inspired, or better, human-inspired, and seeks to emulate a cognitive and autonomous approach to the environment in terms of observing, orienting, deciding, acting, and applying experience. As well known, the mathematical engineering discipline that aims to create an intelligent agent that is a machine emulating the human behavior is commonly identified as artificial intelligence. Nevertheless, under this terminology, many specific disciplines are categorized, each one typically dedicated to one specific aspect of the human behavior that is assumed to be emulated. There are some potential applications, some of them already mature, that can be envisaged and explored for first, taking advantage of the increased computational capability already offered by FPGA, CPU, GPU, parallel computing, and cloud architectures. As an example, artificial intelligence in signal classification, texture classification, event classification, command and control, deployment of autonomous agents, and last but not least, artificial intelligence in cognitive jamming. This slide shows our perspective in terms of value chain of technology. On the left-hand side, the list of enabling technologies, which are general technologies and methodologies. Those technologies and methodologies are in fact transversal to many other applications, which is a real advantage because they allow the creation of a wider ecosystem of contributors, including academia, startups, centers of excellence, and at the same time are generally validated in domains of applications other than aerospace and defense, possibly on larger base of use cases. In the middle, the system technologies that at system level represents the core of EMSO in any domain of warfare, and whatever the usage of electromagnetic spectrum by the threat. On the right-hand side, the so-called system of systems technologies, which represent the leap towards a new variety of scenarios and applications. In the following, a focus on manned-unmanned teaming as an example. The latest buzzword in the unmanned world today is manned-unmanned teaming, the win-win situation in the combat domain where the intellect, grit, instant decision-making capability, and the hunch of a combat pilot are being combined with the precision, endurance, and all-weather and all-terrain capability of the unmanned machine. The capability to network EW systems on board different platforms opens the possibility to connect in real time a special mission aircraft to a mission package composed by unmanned platforms carrying, for example, communication jamming payloads. The special mission aircraft will act as a mission command and control with the privilege to change and/or modify in real time the mission instructions and the mission data packages. The special mission aircraft will fly at a very high altitude and at a safe distance from the playground in order to have a good visibility of the electromagnetic order of battle, and the mission package will fly at a very low altitude in order to be as less detectable as possible towards the playground. The special mission aircraft can download the updated mission data package in the combat platform in real-time information and can act as early warning, giving to the mission platforms the indication of incoming threats according to the electromagnetic order of battle and to the platform course. The coordination of the mission is performed through a dedicated EW link using, for example, the capability of the wideband jammers. The mission consists in a defense activity performed by the UCAF number 2 and an attack one performed by the UCAF number 1. Thank you for joining this short webinar. On behalf of Electronica Group, I wish you all the best and do not hesitate to contact me using the attached email address.